Hello students. In this lesson, we will learn how to divide powers. This is from lesson 3, which is multiply and divide monomials. This is part 2, divide powers. Let's assume that we have the following example. We have 2 to the 4th power divided on 2 squared. How can we calculate this? The simple way to calculate this is that we can write each factor with its components. So we can write 2 to the 4th as 2 times 2 4 times. So 2 times 2 times 2 times 2. This is divided on 2 squared, which is 2 times 2. Now we can cancel each number from the numerator with a number from the denominator. So we can cancel 2 by 2 and 2 with 2, which will give us 2 times 2. Now how can we write this as an exponent? We can see that it is the same base. We can write 2 times 2, and because they have both the same base, we can write 2 to the power of how much? This is a repeated factor, repeated 2 times. 1, 2. So we write it's 2 to the power of 2. So the answer will be 2 squared. Now look at this. We have 2 to the 4th divided by 2 to the second power, and this gives us 2 squared. What can we conclude as a rule to divide powers from this equation? Yes, exactly. We can see that it is 2 to the 4th minus 2 that gives us 2 squared. So we can conclude that when we divide monomials, we simply, if they are the same base, we simply subtract exponents. Let's take another example. Let's take 3 to the 3rd power divided by 3. As we have said previously and repeatedly, any number that is written without any exponent, its exponent actually is 1 to the first exponent. So now how can we calculate it? In the ordinary way, we can write 3 times 3 times 3 divided by 1 3 in the denominator. So we can cancel a 3 from here with this 3, which will give us 3 times 3, which is actually 3 squared. Now we can notice that it is the same process. If we want to calculate it instantly, we can follow the rule which says that we can write 3 to the power of 3 minus 1, which will give us 3 to the second power. Let's take another example and solve it in the rule instantly. Let's assume that we have 4 to the 5th power divided on 4 to the 2nd power. How can we calculate this? The same way, we write the same base. Because we have the same base here, we just subtract exponents. We subtract the second one from the first one. So we write 4 to the power of 5 minus 2, and this will give us 4 to the 3rd power. As simple as it is. Let's take another example. What if we have the following fraction? 6 to the 5th times 2 to the 4th times 7 to the 7th divided on 6 squared times 2 squared times 7 to the 4th. How can we solve this? Actually, we can rewrite this fraction into the form each digit with a similar digit can be a division, can be divided into divisions. Okay, so we can write 6 to the 5th divided by 6 squared times 2 to the 4th divided 2 on 2 squared times 7 to the 7th divided by 7 to the 4th. And then we can apply our rule to each one of these fractions. So we can write 6 to the 5th divided by 6 to the 2nd gives us 6 to the 5 minus 2 times 2 to the power of 4 minus 2, and then multiplied with 7 to the power of 7 minus 4. And our final result should be 6 to the 3rd times 2 squared times 7 cubed. What if we have variables in the question? Let's take the following example. If we have 8x to the power of 14 times y to the 9th power divided on minus 2 x to the 7th power y to the 3rd power. How can we solve this? Actually, we do it the same way. We have numbers with numbers, divide numbers with numbers, each variable with its similar variable, x with the x, y with the x, y with the y. Okay, so the same basis here, y here and y here, x here and x here. We need to write it in the same base. So we can rewrite this fraction into the form 8 divided by negative 2 times x to the 14th divided by x to the 7th times y to the 9th divided by y cubed. We simply write negative 4 times, how can we calculate it? 14 minus 7, which will give us x to the power of 7 times y to the 9th minus 9 minus 3 will give us y to the 6th power. So this will be our answer here. Conclusion: the division rule is used if we have the same base, let's say some constant number a, to some exponents, let's say 5, and is divided on the same base again with a power of something else, let's say 3 here. The second rule states that if we have the same base and a division between them, the same base with a division between them, we simply subtract exponents. We subtract the second one from the first one. That's it. Thank you.